The expansive route traveled by CSX trains puts demands on motive power and crews that are as tough as those on any other railroad in the world. CSX was one of the first major railroads to use the GE-8. This computer-controlled and technologically advanced locomotive combined high horsepower with fuel efficiency, and, equally important, provided high reliability with microprocessor-assisted maintenance and troubleshooting. With the rail industry becoming increasingly competitive, CSX has once again turned to GE for the latest advances in locomotive technology. The newest addition to the CSX road locomotive fleet is AC powered. Let's take a look at some of the differences and some of the similarities between the new AC-powered locomotives and the locomotives with which you're already familiar. Although the new units resemble the -8, there are some subtle changes in appearance. There's a third dynamic braking grid stack that provides additional braking effort. The auxiliary cab behind the operator's cab has been completely redesigned to house the inverter electronics. An integral safety bar removes power and automatically discharges the high-voltage circuits. When the circuits are charged, the LEDs are illuminated. Make sure the LEDs are out before you enter the compartment or work on any power circuits. The latest units have low-weight transfer, high-adhesion trucks. The performance benefits are more obvious. Let's take a look at the increased performance capability offered by AC power. Continuous tractive effort has expanded from approximately 108,000 pounds to 145,000 pounds, an increase of 30%. While a typical -8 starts at 140,000 pounds, starting tractive effort on the new AC units is rated at 180,000 pounds. The AC follows the same curve, but at a higher tractive effort and higher operating speed. This increase in tractive effort means that when computing the maximum number of axles allowed in motoring, these units are considered as 9-axle locomotives. A graph comparing the dynamic braking effort is even more impressive. AC locomotive design provides a striking improvement in dynamic braking over conventional DC units. The AC braking curve resembles the DC curve at the higher speed. With AC technology, dynamic braking effort has increased 27% from 78,000 pounds to 98,000 pounds and is maintained smoothly to almost a full stop. Again, these units are considered to have 9 axles when computing the number of maximum allowable axles during dynamic braking. Improved computer monitoring and diagnostics automatically compensate for problems in the traction motor circuits. A problem with a traction motor may now be identified, isolated, and even result in the motor being cut out and the power transferred to the remaining axles without the operator's assistance. This seamless operation provides smooth, steady power and braking control over the unit's entire operating range. The new unit's all-weather adhesion capability is up 7%. There's a 10% gain in horsepower with the same prime mover, the 7FDL. Some of the new AC units will be delivered with a newly designed 6,000 horsepower prime mover. This means a 36% rise in horsepower. Faster movement is now possible with the top speed climbing to 70 miles per hour. Maintenance on the new AC locomotive has been simplified. Many procedures can now be performed on the service track. Improved access to all of the control components makes diagnosis and repairs easier and faster. The new AC motors are designed to go 1 million miles between overhauls. They have fewer components and are fitted with an integral shaft pinion that eliminates slipped pinions. These powerful new motors run faster than their DC counterparts, producing more horsepower in the same size frame. The AC motors are in the high-adhesion trucks. This revolutionary truck design provides maximum all-weather adhesion through a low-weight transfer system. The negative result of variations in track and torque effect has been minimized by redistributing the locomotive's weight and repositioning the traction motors, improving adhesion. The new trucks are part of a newly designed suspension system that improves ride quality. The inverters are air-cooled. This eliminates the possibility of coolant leaks that could have an adverse impact on the environment. Drawing from GE's extensive background in AC transit, the locomotive design engineers have produced a single inverter per axle system that provides the highest possible tractive effort per axle, maximum torque that is unaffected by individual wheel diameter variations or the loss of a traction motor. Unlike earlier locomotives, the dynamic brake isolation feature allows the unit to have dynamic braking even if a traction motor has been cut out by you or by the computer, ensuring high mission reliability. The new GE CSX AC locomotives are equipped with ergonomically designed integrated function computers. This GE-developed AAR industry standard monitoring and control system eliminates cab clutter and centralizes important train handling information on interactive display units, IDUs. There are 2 screens for the operator and a look-only screen for the crew. Let's take a look at what you'll see when you operate a locomotive equipped with interactive display units. You already know how to use all of the information. The only difference is the way it's displayed. Instead of a console of dials with needles displaying air information, there are graphs and digital readouts. The equalizing reservoir and the brake pipe pressure are shown in both formats. Brake cylinder, main reservoir, last car, and airflow information are numerically displayed below. The speedometer simulates the type of speedometer you're used to seeing and has an additional digital speed indicator that lets you see your speed with just a quick glance. The load meter has been replaced with a bar that displays kilopounds of pulling and braking effort. A digital representation of the graph is available immediately below the bar, along with reverser and throttle call information. A row of indicator boxes below the middle of the screen displays the independent and the automatic brake status, end of train ID, marker, and fuel information. The assignment of the keys at the bottom of the screen is updated to match the operation you're performing. Pressing F3, operator function, changes the key assignment and takes you to the operator function menu. By following the on-screen instructions and pressing the appropriate keys, you can customize the locomotive setup for any freight handling assignment. Pressing F1 activates the distance counter. The display changes to the distance counter menu, and you can press F5 to preset the distance counter to any 5-digit number. You may press the keys to count up, count down, stop the counter, and reset the counter to 0. F8 takes you back to the previous menu. The electronic air brake setup menu is next. The IDU screen and the key assignment change again. Now, F1 and F2 control the feed or regulator valve setting. When any of the setup keys are pressed, the screen displays the new changes you're making, along with a reminder that the new air brake setup hasn't been saved. F3 cuts the automatic brake out and in. The F4 key that allows you to choose between trail and lead operation replaces the MU2A valve, which you've used on conventional locomotives. F5 and F6, the consist size controls, adjust the actuating time of the locomotive's brake cylinder pressure. When you've set all of the parameters to the correct values, press F7 to save the new setup. Press F7 again to confirm that you want to save the new setup. If you want to leave the electronic air brake setup section without making any changes, press F8 to exit. On units equipped with electronic air brakes, there are actuating buttons on both brake handles, which, when pressed and held, release the air brakes in the consist. Back at the operator function menu, F3 takes you to the end of train setup. After you've used the keys to enter the transmitter code for your train's end of train device, press F6 to enter the code. Pressing the test button on the EOT device at the end of the train causes the display in the EOT status box to change to Arm Now. Press F7 to arm the system. Once again, F8 allows you to exit this setup section and return to the operator function menu. If you want to reduce power, that is, control either the locomotive speed or the percentage of power available at the current throttle setting, press F5. The manual power reduction screen appears. Use the F6 and F7 keys to set the throttle notch percentage, if necessary, before you start the manual power reduction. F1 toggles the function on and off. To set up the automatic speed regulation option, use the F4 and F5 keys to adjust your locomotive's target speed in 1/10 of a mile per hour increments. The speed reference bar compares your selection to your present speed. While these adjustments, from 3/10 of a mile per hour to 10 miles per hour, have no effect in manual mode, they should be set before you enter the automatic speed regulation function. As your speed approaches the center of the speed reference bar, press F2. The computer locks on to the selected speed, and the automatic speed regulation screen appears. The light-heavy function keys adjust the computer's sensitivity to changes in train loads. Moving the throttle to idle or pressing F8 to exit the screen turns off the automatic speed control function. Next on the main operator function menu is F6, the operator tests key. You may press F1 to perform the alerter resets. Follow the instructions on the screen. Performing any normal locomotive function resets the counter. When you're sure the alerter is operating properly, press F8. To perform a measured mile check, press F2. During this test, the locomotive speed under your control must be constant. Press F1 at the beginning of the measured mile. At the end of the measured mile, press F2. Your actual speed appears on the screen. As always, F8 takes you back to the previous screen. Pressing F3 and F8 tests the end of train device by entering the terminal test code number. A second press of F3 restores the original number. Press F8 to return to the main menu. The final selection is F7, Screen Controls. F1, the alarm test, enables you to check to see that all alarm indicators are operating. IDU screen brightness is adjusted by pressing F3 and F4. Sensors measure the light in the cab and maintain the brightness level you've selected, whether you're in bright sunshine or traveling through a tunnel. Holding in the alarm reset button on the console for 5 seconds returns the displays to their normal brightness. IDUs make it easier for you to monitor important train handling information. This is even more important now since GE's Quiet Cab not only blocks out annoying road noise, but some of the air brake sounds as well. Remember, you can get accurate, updated air brake system information from the IDUs at all times. Like all GE computer-controlled locomotives, accidental direction change is prevented above 3 miles per hour. To better control adhesion, the computer prevents manual sanding above a preset limit. The new CSX AC locomotives are equipped with the latest advances in diesel engine technology, including electronic fuel injection, EFI. When you start an EFI-equipped locomotive, you must allow a few extra seconds for the fuel oil pressure to reach about 60 psi. Eliminating the rack means that there is no lay shaft. With EFI, starting is faster and more reliable. Split cooling lowers engine intake air temperature. This new technology maintains optimal running temperature. This allows the fuel to burn cleaner and more efficiently, increasing engine performance and dramatically improving reliability. At the same time, fuel consumption, exhaust emissions, and visible smoke are reduced. CSX Transportation is grateful to you for your contribution in making CSX a leader in the transportation industry. The investment in the new AC-powered GE locomotives represents CSX's commitment to provide its crew members and workers with the most advanced locomotives ever built. But we also know that even the most advanced systems still require a commitment from you, the well-trained and dedicated CSX employee. With its emphasis on safety, reliability, and ease of maintenance, and your help, these new GE locomotives will be leading CSX and its trains into the next century.